This is how I plan to prove my work physically, to prove my theories, my diagrams and geometry and theories physically. This is a cross section of an invisible cube. That's what I call it. It's actually a large cube, about a 1 foot square cubed. And these were the things I were going to use on it, like racket balls. I was going to cut them in half, and they would represent a pixel, a 3D pixel on the outside of the cube. And another thing I was going to employ was ping pong balls that would represent cut them in half, and that would represent the three-dimensional picture elements on the interior cube. This is just a cross section, but the interior cube would be called the light interface, and that's what makes invisibility and holodeck technology possible. And those two things, those two 3D picture elements would be linked together through through bundles of reflective coated, mirror coated plastic tube, like fish tank tubes, and that would send light through from one angle to go through and come out and hit its corresponding three-dimensional picture element on the other side, its three-dimensional ping pong ball, and come out through the bundles of tubing, reflective tubing, and back out the same direction it came in at same angle it came in at, all around the cube. And this cube is very, very low resolution in visibility and holodeck. It depicts a holodeck on the inside scenery of the outside environment, but it's very low resolution. I'd compare it to the resolution of a calculator. But the tubes would act like fiber optics, but this is a plastic fiber optic toy. But it would act to send like a laser pointer through the bundles to their corresponding exit points on the three-dimensional picture elements on the light interface, and out at their corresponding angles to their receiver picture elements, or bundles held in place by three-dimensional picture elements, half sphere ping pong balls, and back out at their three-dimensional picture elements. What I'm representing there is my proposed three-dimensional light interface pixel system. Here's the large picture element for the outside surface of any object you want to make invisible. These are the inputs. These are the holes around the surface of the three-dimensional picture element. These are the bundles of tubing, and this is the three-dimensional reflective tubing, which corresponds to fiber optics in between these specially made 3D picture elements. And this is the half sphere ping pong ball, and that connects to the light interface on the surface of the light interface. It connects on the surface of the light interface. This is the outer picture element when cut in half, done properly, and this is the inner picture element. And this is the tubing. I'm planning to make a real version of my invisibility that you can use a laser pointer to shine through, and anything tucked within this area, moving these fiber optic bundles out of the way, moving these tubings out of the way, and stuff something like a teddy bear or anything in this area, you would see light go around it because it's making its way through the reflective bundles. This is what I just recently drew today. This is a three-dimensional perspective of the invisible cube. This is the three-dimensional perspective of this, and here you see the three-dimensional picture elements on the outside surface, and here's a cutaway showing the bundles, the reflective bundles going to their corresponding three-dimensional picture elements on the interface, which takes the same shape as the object you want to make invisible. And then inside here on the light interface, which is the cube within the cube, is a breakaway of the interior where the light is switched through to the corresponding angles on the other side. And this is all made out of probably wood for the box itself, something like racket balls cut in half for the outside 3D picture elements, and ping pong balls cut in half for the inside 3D picture elements on the light interface with the cube inside the cube. is the light interface, and the bundles in between is the tubing, the reflective tubing, painted chrome, fish tank tubes painted chrome. And when you shine a laser light behind and hit one of these openings in the three-dimensional picture elements, it should make its way through at whatever angle you send it through, if there are enough 3D fiber optic bundles or reflective tubing bundles to match up to the light angle that you point your laser light at. So this is one way to prove my theories, is to actually demonstrate on a very, very low resolution level invisibility, actual invisibility, without the need for expensive electronics. You're just doing the same thing that fiber optics and custom-made 3D picture elements would do, but on a larger scale. But you could hide something in between the outside surface and the inside 3D, the light interface, in between the fiber optics. If you moved them out of the way, the reflective tubing, which stands for the fiber optic wires, and you can hide a teddy bear or something in between, and you could send light through as if the teddy bear wasn't there. So this is my description of what I plan to do. This is a thing that I wanted to do after I got out of the hospital because I was vomiting blood from drinking, which I haven't drank since April 19th. And this is my first project that I put on the back burner. But now I think I'm about ready, as soon as I can learn how to properly cut racket balls and ping pong balls without melting the rubber of the racket balls, or without cutting the flimsiness of the ping pong balls. And I can construct this. All I have to do is paint the tubing chrome or mirror paint, and light would reflect inside the tube, and connect it from the outside 3D picture elements to their corresponding 3D picture elements on the light interface. Would be how you would send light through in a very, very primitive, low resolution invisibility, and on the inside would be its inverse, holographic scenery of the outside world going through. Well, I hope I explained this enough, and I know this is going to take a long time to upload to YouTube, but just be patient, and hopefully you can get through this, if I can wait as long to upload it to YouTube. Well, thanks a lot for looking at my ideas, and this is one thing that I'm not going to keep on the back burner for long. Well, thanks a lot. Bye-bye.